Once again, welcome to this session and good evening, everyone. As you are aware of, in the last session, we discussed about the Ethernet as the IP, how that IP is, integrated within the SoC. And today, we are going to discuss about the Ethernet enablement, how we are going to enable Ethernet, and we are going to take few automotive use cases. Why Ethernet is selected in the automotive? What are the reasons for that? So with this objective, let's start. This is my brief introduction. I am working with the automotive processing software R&D group, and I am based in Noida. And my total experience is close to now 25 plus years of experience, and mainly 15 years in automotive. And before that, I was I enabled set-top boxes, so mostly embedded system design and development. Today, agenda of today's session is a brief 2-3 slides about NXP. As you are aware of, a lot of students are going to join or already joined this session. So just a brief introduction on what NXP is, and then how NXP is architecting the car of the future, Ethernet in automotives, vehicle networking, and why Ethernet in car, and what is for us. This is very specific for the students. If they want to shape their career, what they need to do. Okay, so our punchline, NXP, secure connections for a smarter world. So this shows that connectivity is the prime, objective or the prime focus or the prime business area for NXP, and secure connection is our motive. Here in this slide, this is just R&D engineers data. So we have now 11,000 plus engineers, and this is a little older data. Now we crossed 10,000 plus patent families, and we are one of the top 10 semiconductor company. We are the leaders in radar solutions, secure edge processing solutions, edge connectivity, ultra low power designs, and pioneer in the embedded hardware security. How this converted into the designs. So we are enabling a lot of applications on the cloud infrastructure, mainly for automotive, industrial, mobile, and communication infrastructures. How we are doing that? So focus is on the security, authentication, data analytics, services, and the machine learning, AI and ML. What is the main enablers? We have 4 basic pillars: sense, think, act, and connect. We'll discuss this in the next few slides. And edge-to-edge communications. So in edge-to-edge communications, we have home gateway, automotive gateways, smart city, all type of smart, networks, home, health, retail, wearable devices. Robotics is our focus as on today, smart building and smart automotives. Then our target markets are automotive, industrial and IoT, mobile, and communication infrastructure. So automotive, you are already aware of. We are number 1 in automotives. We have good market share in industrial and IoT, in mobile also. All this NFC, secure payment gateways, 5G. So all are enabled on our processors. Now, what is sense, think, connect, and act? So sense is mostly the sensors to collect the data, analyze the data. And then think is basically the microprocessor and microcontroller part that you have to process the data, do the data analytics on that. And then based on the actions, you have to connect, and then you have to act. So this is the theme of all our system designs. So when we are saying sense, so everything should be aware, smart sensors mainly. And then think, everything should be smart. The microcontroller and microprocessors, everything connected, it's a connectivity, and everything is efficient. We have to act fast, low power. And the punchline is everything safe and secure. So main applications where our focus in last few years and for next few years also, which is ultra wideband. Everybody is aware of how much we are investing, and we have few successful design wins with Samsung and other companies. So ultra wideband in not just in mobile applications, but also in automotives, a lot of applications there, and in IoT and wearable devices. Then 5G infrastructure already deployment is started, a comprehensive antenna to processor portfolio. And we are working not just globally, but also pioneer in India. We are closely working with Jio to enable the Jio infrastructure and all. V2X, which is vehicle to infrastructure, we will discuss in detail. But yes, we have now deployment started in field, and a lot of major customers which we are working on. Then Wi-Fi and Bluetooth, we have a complete portfolio. Wi-Fi 6 is recently enabled on the different types of applications. And then the edge connectivity, which is our main focus area, and a lot of deployment happened in these areas. Now, how we are architecting the car of the future. So our focus, whenever we are designing a new SoC, so our focus is autonomy, which is zero road accidents. You guys are very much aware of how many accidents are happening on roads, and 90% of the accidents are basically due to the human errors. So we have to make our systems smart. To our company's objective is zero road accidents, so we can save lives. Social cause also. Then electrification, we are very much aware of the zero emission is the demand as on today, and EV is the focus, not just in India, but in most of the countries. The targets already set. Somewhere it is 2020, 30, 2030, 2040, 2035. Most of the, in few years, all the countries will be, their targets are 200% electrifying. So we can fight with the carbon emissions and the pollutions. The third is connectivity, and this is a very important factor as on today. If connectivity is not there, we feel we are not tech savvy. So our senior citizens are also nowadays, they are well connected, maybe through mobile, through any other WhatsApp, a lot of other applications. And as per the data, generally globally, not in India, but globally, people are investing at least 2+ hours. But in India, I think if someone is coming from Gurgaon or somewhere else from remote locations, they will be approximately 3+ hours they are investing. So connectivity is the key ingredients in the automotive going forward. And how it is going to be used in that, we'll discuss later. Now, Ethernet and automotives. So you guys are very much aware of that. In automotive, if you can analyze, the base model is approximately 1/10 of the price, the top model price. 1/10, not 1/10, basically 25 or 30% is the base model cost, and the top model is having a lot of electronic features, a lot of electronics. The top model is also having the same engine, same body, same chassis, everything is same, but all cost, which is almost contribute 60% cost is with respect to the electronics and different types of features. So when this type of electronics, I don't know whether you are aware of or not, previously approximately 300+ microcontroller microprocessors were installed in the car for different types of applications. But going forward, in the last Electronica event, there was some discussion with the Audi and Mercedes and BMW. The discussion was approximately 6,000+ such smart devices are going to be installed in the car. Very surprising factor. And Lars, in our last week's visit, he shared this data when he discussed basically with all those global leaders. So yes, our future is bright, I can say that. But yes, this will increase the complexity within the car. And as on today, the electronics and electrical components, lot of wire harness in the car. And to enable all these features in the car, the wire harness is increasing day by day. So the present network which is installed or the wire harness in the car is not sufficient because the weight of the car is increasing. And when weight is increasing, it is going to be impact the efficiency. And during the EV, this infrastructure is not going to work. So we have to think smartly. And how we thought of smart as the Ethernet. And BMW was the first in this industry who enabled Ethernet in the car. And maybe if you NXP guys, I think in this program. So long time back, we enabled Salsa was the device which enabled Ethernet in the car. So we were the first one in this industry. Now, long way. Now we have very smart devices in our portfolio, which will enable not just Ethernet, but also very high-end Ethernet communication plus the gateway and all. We will discuss in subsequent slides. So it shows the automotive Ethernet market, worth 4.4 billion, only Ethernet basically. It's not the whole system and all by 2024. And what are the major applications which are going to be enable this market is ADAS. ADAS is the Advanced Driver Assistance Systems. Mainly if you see the central console or the dashboard in the car. So a lot of sensors are installed in the car, which gives the data, and based on that, analysis the lot of different types of indicators available for the driver to understand the situation and take the decisions based on that. So it is basically the Advanced Driver Assistance Systems. Then the connectivity, although this connectivity is not enabled in most of the cars, in the very high-end car, this is enabled. But going forward, I think by 2025, there will be not a lot of models, but few high-end models are going to be launched in the market with all those connectivities. AI ML based applications, a lot of things are there. Radar and vision based systems already installed in the car that we will discuss. So the main point is we need a very robust system in the car, communication system in the car, to handle this huge amount of data in the real time with low level of latency. A very reliable and high speed network is required. And I think answer is the automotive Ethernet, which is the right fit for these types of applications. Now, how it is going to be enabled? So I just want to give you a very top level picture of this. You have the Ethernet controller within the SoC, and which we are saying MAC. And out of the SoC, you have to install some PHY, which is basically the Ethernet PHY. And after Ethernet PHY, you have some transformer to handle the magnetism. And then you have the RJ45 connector. So this is our type of infrastructure. And then this is connected. And on the other end, a lot of other systems are hooked up on that channel. So this is a very top level, very high level of infrastructure for end-to-end Ethernet communications. A lot of innovations are happening. We started with a very basic Ethernet, and as on today for automotive we have serial gigabit media independent interfaces. So SerDes is one of the interfaces, SGMMI, which is handling 1.25 gigahertz or 3.125 gigahertz of communications, and this is RJ45. Nowadays this transformer is also inbuilt with the RJ45 connector. So this connector is having all those magnets. The next is the reduced gigabit media independent interface, which is RGMMI. The only difference between these is speed as well as the low pin counts. So that is also important for the automotive communications. Then GMMI, which is a gigabit media independent interface. So GMAC is the interface within the SoC to connect the RJ45 connections to enable Ethernet communication. And then the reduced media independent interface, RMII, which is again the MAC. and the media independent interface, which is MMI. This is very old, 10 by 100 ENET files. So this all pictures from the web. Now in automotive, there are different types of cable connections. The UTP, which is the first picture, this one. So unshielded twisted pair cable consists of two twisted cables without additional shieldings. It will handle up to the data rate of 100 Mbps or 100 base T1. And the second one is the shielded twisted pair to handle the noise in the car, or we can reduce the interferences. SPP is this one, the shielded pair cable, which includes two parallel cables which are shielded, and these pairs are not twisted. So the skew of SPP is lower than the STP. Coaxial cables, this one. This has the advantage of low cost in respect to the other cables, but the drawback of this cable is the lack of immunity against the external noises. So a little bit tough to install in car. STQ is basically the two opposite conductors which carries differential signals, and the other two perpendicular lines which creates virtual ground between these two cables. So a copper layer around this whole line shielded the cable separate. The twin axle cable consists of two parallel cables, having a joint shielding. So this is also used for differential signaling. So these are the different types of you can say cables and connectors used for automotive Ethernet. Now certain recommendations when you are designing the boards. So based on the board designers and the different types of problems we faced, we are suggesting these recommendations. So I will I will go through all these things. So selection of PHY depends on the type of interfaces which is being used. It will must meet the timing and the electrical requirements, and these requirements are going to be matched with the processor or the microcontroller which you are using for the data sheet is going to provide this type of data. The TX line from MAC and PHY, must have provisions to add series termination. This series termination is very, very important to reduce or handle the noise levels. The SoC provides programmable drive strength options to match the impedance of the data lines. So the connectivity between the MAC, the PHY to the magnetism. So you have to match, all the impedance of the data lines. PHY reset pin connected to the reset pin from the processors. This is a common, guidelines. Clocking in the RGMMI interfaces must be source synchronous and must also have provision of the series termination. Series termination is almost must as per our experiences. Reference clock source, we have to use an appropriate clock source as per the MMI protocol requirements. All protocol requirement, external clock must ensure that the clock is shut down or disconnected before entering in the standby mode. This is the best practice basically. The MDIO line, digital input output line, pull through based on which type of PHY you are using, but the recommendation is between 2 to 10 kilo ohm resistor to the IO voltage of the PHY. The PHY data sheets are giving you this data. What type of pull-ups will be required for that? The TX and RX pair must be routed in a single layer. So the PCB layers have 8-layer board or 6-layer board or a 4-layer board depending upon your requirements. The suggestions are that you have to route all these layers on a single layer to minimize the noise levels. Air gap between signals must be of 2 width. 90-degree trace corner must be avoided. So when you are putting the traces, you have to avoid the corners within 90-degree traces. Max length to be achieved not more than 3 inches from MAC to PHY. The purpose of series termination is to reduce reflections and improve the signal quality. Try to keep spacing between intergroup and intragroup signals with more than 3 bits spacing. All transmission lines, receiver lines, clocks of transmitter and receiver signal groups must be matched plus minus 50 mils of tolerance. The RJ45 Ethernet connector is recommended to have metal shielded so that connected to the chassis ground to reduce the EMI emission, EMI, ESD, and all this. A lot of problems in automotive. MDI pairs must be routed close together in parallel to reduce the EMI emission and the common mode noise. Consider the required clock to data skew as per the RG-MI specifications, and please follow the data sheets. These examples are given based on our latest processor, which is very popular in the gateway applications with the S32G from the timing delays. So we discussed about the board. Now your board is perfect. You have to understand the different layered architecture of the Ethernet communications. The physical layer, the Ethernet signal and cabling is done in this layer. Then the MAC layer, which is responsible for transmit packets from node to node and based on which station is. Then the network layer routes data to the different lanes and vanes. Then the transport layer, which ensure the delivery of the entire file and messages. Then the session layer, which is start, stop, and even control that. A very important layer is the presentation layer, where the encryption, data conversion, and all these things are happening there at this stage. And then finally, the application layer. Mostly customers are working in this area where what type of different types of applications they are using, and they are going to enable in this zone. Now, vehicle networking. So just to give you the glimpse of a long time back, no connectivity. Then we started with analog radio. So Philips was the pioneer in this AM, FM communication. Then we went to Wi-Fi and Bluetooth within the car. Then nowadays 2G, 3G, along with the C1. And then going forward, we are talking about not talking about DRM, satellite radio. All these are already implemented. C3 is already in the market. And going forward, 5G, V2X connectivity, some implementation already started. But yes, in a very initial stage, or the testings are going on, field trials are going on. And going forward, the driverless car or the fully connected car, where all these different types of connectivity. Now, so just to give you the communication infrastructure, we started with LIN in the car, which is handling 20 kbps type of bandwidth. Then CAN and CAN FD, which will handle 1 megabits, 1 Mbps. FlexRay up to 10 Mbps. Then Ethernet, initially we tested few years back up to 100 Mbps, and now multi, Gbps Ethernet is already in testing. So LIN can handle, body control applications. Then CAN is mainly, used for the invented by Bosch, mainly for powertrain and chassis applications. Then connectivity, ADAS, and autonomy. So you can see transmission box to gateway, radar to central compute, camera to central compute, head unit display. Our Hello device, we developed long time back, and now it is in the field. A lot of cars are enabled with that. Head unit to display, and then the cross domain backbone. If you see the requirements, initially it was 1 Mbps. Now going forward, the requirement 20 Gbps, and still it is not satisfying the requirement of the network. So you can see this picture. What type of wire harness in the car? So this is the basically main idea to replace all those things with the Ethernet wherever it is possible. It is not possible that everything is going to be transformed. So why we are thinking of growing complexity, increasing the connectivity, and increasing interdependencies. This is, you can see one of the box here. So it is every box is called ECU in the car. And then this ECU is basically, different layered architecture, connectivity, monitor, supply, then the sensor interfaces, and how this sense, thinks, and act is implemented here, the MCU part or the microprocessor part or the driver part. One more, level down, you see the network in the car today, not today, this is a little older picture. Now it is, but in most of the cars, still this is the architecture, low bandwidth, flat network, one MCU per application. And in mid segment or high segment car, we have now domain architecture. So domain means one application, like EV powertrain is one application, body is one application, ADAS is one applications. Then you have connectivity is one, infotainment is one, and then the domain, central domain, which is gateway. This is going to handle all these domains basically. The infrastructure may be anywhere in the car, but like infotainment or in-vehicle entertainment. So all the things like backseat entertainment, center console, all these are going to be connected with a central domain, and that domain is going to be connected with a central gateway, and that this gateway is going to be interconnected with the outside world. So this type of infrastructure is in few of the car, but there are one more, although some problem in this type of infrastructure and different types of OEMs, they are, implementing the architecture in their automotives in a different way. So this is also very popular and going forward, like zonals. So car is divided into different zones, and one zone is going to be handled by that particular zonal gateway, and this will handle all the applications in that area basically. And this all the zones are going to be connected with a central brain, and the central brain is basically connected with the outside world. So this is a focus for the going forward, how going forward we are going to handle the different types of communication. And without Ethernet, we cannot survive in this. Now, there will be challenges. So what type of challenges for us? What type of challenges for us from the processor side? The performance is one of the important. Power consumption is one of the important thing. So performance is the first, you can say the highest top level requirements to handle all these new applications. Then the data bandwidth. So CAN FD and Ethernet both will go hand to hand. And going forward, the connectivity with the external world through central brain, which is going to handle 5G and all other megabit and gigabit data rates of communications. Then if there are 6,000 plus uh, ECUs or the nodes within the car, then the lot of data is going to be the node is going to be changed. And when data is moving from one node to other node, the security is the key ingredient for that one. So public key infrastructure, asymmetric cryptography, key managements, OTA services, and then demand for intrusion detections and prevention system, continuous monitoring system, countermeasures, side channel attacks, cyber security, lot of stuff there. So security is also major criteria for selecting the microprocessor, and function safety. If it is a automotive applications, yes, for sure, function safety is the key ingredient for us. And SL is the different types of category A, B, C, D for different types of fail-safe operations. For security is PKI support security escalations for data bandwidth, hardware networks to be accelerated to offload the processor, hypervisors, and all those different types of implementation we are working on. And how we can increase the performance, high performance, low power, multi-core, heterogeneous processing. And going forward, we are now thinking of the subsystem based architectures, so that we can manage different types of applications and a very good connectivity between those processors. Now, if the processor is so complex, what type of networking challenges we are going to face? So routing and network address translations. If there are 6,000 nodes within the car, the forwarding frames based on IP address, the update VLAN priority, source destinations, a lot of complex softwares, a lot of algorithms to be implemented. Firewalling, network security is must. We need dedicated resources to handle and monitor that. Intrusion detections and preventions, statics based applications that monitor the network. Unauthorized, unauthenticated, we cannot allow to that. A single channel, which is as mentioned, the brain of the system. At that level, we are going to analyze all those things, and then we are going to pass on the things to the system, and a secure connections. So SSL, IPsec, all those type of secure communication mechanism we are implementing in our new generation devices. So just one example here in our previous gateway devices. So we have different types of smart packet handling implemented in this one. So inter-domain. So you have different types of issues. Then you have the Ethernet. Those are connected with the Ethernet switch. Ethernet switch is connected with the smart packet forwarding engines, and all these infrastructure is connected with the host. So host is going to drive that. So directly, one traffic is like host is going to do. You have to pass all the stages and then transfer the data to the other node. Or there are certain options available in our controllers direct through switch. You can transfer from, let's say, from LIN to Ethernet, or maybe other different types of interfaces which are available in our devices, or maybe the packet forwarding engine, which is a smart you can say a system which will handle all the Ethernet connectivity. So from CAN, you can forward the packet to other devices by converting them into the Ethernet and all. So different types of connectivities implemented in our processing to handle this type of communication or this type of packets, which is changing one node to another, interdomain, intradomain, and intradomains basically. So these are the different types of path which is which we created. So 1, 2, 3 is already mentioned here. So the longest path will be when host, the CPU is basically going to handle the communication, and less is at the level of packet forwarding engine, or the simplest one, or the shortest and the fastest path is through the Ethernet switch. So Ethernet switch is also very smart from our IVN group, which is in vehicle networking. So we have very smart switches there, which will handle different types of Ethernet services. Now, I will share some statistics. So this data is downloaded from the Gartner's, and the connected vehicles 38 million was shipped in 2018. I don't know what is the data as on today, but the prediction of market is, if we considered total was 40% in 2018, so it is going to be increased by 73% in 2025, and it is going to be, growth is very high. And the vehicle data, 4+ terabytes of vehicle data is going to be, uploaded or transferred per hour. And if you are, driving the car for 4 hours, 4+ hours, then you can imagine what type of data. So how much data handling, the data analytics, intelligent detections, security implementations, safety requirements, data, analytics, AI, ML implementation, lot of stuff are going to be implemented. Market requirement. And how this data is going to be used in different applications. So predictive maintenance, this is one of the main feature. Then advanced vehicle diagnostics. So car will, self-diagnostics there whenever there is issues through the ADAS, it is going to be informed to the driver, or it is the car will take the controls if driver is not going to take the controls. So a lot of features are going to be implemented in driverless cars. And the usage-based insurance, right now, as you are aware of, the insurance cost premium is fixed for everyone. But going forward, based on this data, like in the health insurance, if you are not going to take any insurance, you will get bonuses for that. In a very similar fashion, going forward, based on the uses of the car, based on how safely you are driving the car, you will your premium is going to be based on that. The telematics and the fleet management, customer 360-degree view. So outside view is going to be based on the personalized. You can define and implement this usage and feature analytics, public safety related things. And how these are going to be different types of applications within the car. So vehicle-wide over-the-air updates. So while the car is in the charging mode, or it is in the garage, or it is on the road, everywhere, whenever any issues identified, any patches comes, like we are working on laptop, and in the background, a lot of things are going to be upgraded. or updated, or the patches are going to be applied in a very similar fashion. It is going to be, part of in our vehicle going forward. As to cloud or data analytics, a lot of, you are going to train the data on the clouds, and whenever it is required, it is going to be fetched directly with a very high speed and implementation of different types of advanced algorithms there. So data analytics can be done on that. Virtual ECUs, the hypervisors, and all those things are going to be used. Data aggregation systems are going to be implemented within the car. Intrusion detection and prevention, very important part when this type of cyber threats are happening. So we were just discussing this going forward. Nobody is going to put gun on your head to asking for money. They will take or hack your car, and then they will ask the ransom monies from you. Like you are, now it is hearing that that website is hacked. Our very secured RBI server is hacked, and they are asking crores of money. And I don't know whether you are aware of or not. This is the major revenue generation for the North Korea. As per the data, no, I don't know whether that's correct or not. But yes, a lot of security, cyber to handle the cyber threats and all. Our processors or the microcontrollers must have a very secure and robust security implementation, data logging and forensic. We have to, do the time stamping of all the data, centralized vehicle security, and many more services to come. So this all is, we discussed about why we need Ethernet in automotives. Now we are going to discuss the use cases of that one. What all futuristic use cases are partially implemented within the car. So we'll discuss first autonomy. No automation is the level 0. So this is based on the level, defined as per the automotive guidelines or standards. Driver assistance is, 1. This is already implemented. Partial automation is already enabled. We'll discuss what is that. The conditional automation is, we are enabling this right now. And level 4 and 5 is more of, when once we have is few things are in testing, but it's not completely implemented. So fully automated car and the driverless cars. So what is level 0? Level 0 is no automation. All the things are manual control. Humans or the drivers are going to take all the decisions. Then the driver assistance, which is level 1. So this is almost, implemented. Cruise control, monitoring speed, a lot of, indicators in front of the driver. So this all the driver assistance. So driver is going to take the decisions based on that. Then partial automation, which is the advanced driver assistance systems. So you are, very much aware of the hill controls, the steering and accelerations related things. If few new cars implemented when some, obstacle detections is already there, radar based implementation. So the car speed is going to be reduced by, 1/10, so that driver can take the decision. And in all these things, driver can take or interrupt any moment of time. This is the first implementation, which is almost, implemented in the car. Now, the conditional automation is basically the environmental detection capabilities. The vehicle can perform most driving tasks, but human or the driver can override is still required. A high automation, the vehicle will perform all driving tasks. In the specific circumstances, the driver is going to take the decision. Otherwise, car will take most of the decisions. Fully automated car where, no interaction from human, and the driver, the car is going to just inform the driver that what is going on, what is happening, and the car is going to take almost, 99% decisions and the actions. Then the second use case is secure V2X. When we are saying V2X connectivity is a major pillar in the autonomous, vehicles. So vehicle to vehicle when you are on the road, vehicle to the network, because network connectivity is very important. Like it nowadays, if mobile is in your pocket, then all the, mobile towers are tracking you, and through mobile towers, your connectivity is across the globe. And then in a very similar fashion, your automotive car or the car is going to be interacted with the networks, vehicle to infrastructure, vehicle to pedestrian, and vehicle to the utility. These are the probable use cases for, and Ethernet is the backbone for all these different types of connectivities. Our trials are already going on in Europe, in the trucks, and in the golf carts and all. So 5.9 gigahertz V2X mass production is already started, and most of the work is done by our NXP Bangalore and Noida teams. The Pune teams also implemented a few of the connectivity related things. So it's driven globally. Major portion was handled by the India engineers. So a lot of scope of work for us. This is a smart key implementation, as you are aware of. As on today, no need to put the key in the car in the start module of the car. You put the keys in your pocket, and by start stop keys, everything is going to work. Going forward, we are working on a smart key where the front panel of the key is like a LCD panel, and all that LCD panel, you are in a remote area, your car is far away from yours. You can see the picture of your car if somebody is going to steal that, or maybe some hampering, or someone is doing some unwanted things, then your everything will be on the mobile. All the related information, you can start the AC before reaching the car, so your car will be perfectly in a good condition to drive. So all those things will be part of this smart key. We are in a process of enabling this type of feature. Very soon this will be available. I think BMW is already, one car is in the market with this new thing. So this is, you see the BMW logo on this one. So this is again the smart connectivity, and internally the modem, or which one is going to be interacted through some satellite connectivity or from the mobile connectivity. I don't know what type of connectivity they implemented here, but mostly through like a mobile connectivity, advanced part of that. So very soon this will be based on this one. So this is also the new solutions in the market. Now the next where we are pioneer and driving the futuristic applications related to radar. So few years back, radar sensors will give the data on the cluster, and driver is going to take the decision, and engine is based on the acceleration given by the driver, and the throttle controls are going to be based on that. What is tomorrow? Tomorrow the radar sensor will be as it is. A lot of data are going to be transferred initially in one radar. Nowadays, almost 12 plus radars are implemented on each side of the car to enable a lot of applications there. So CAN-FD and Ethernet is going to be enable this type of data transfer. Then fusion and planning is going to be happen. The central gateway is going to take the decisions, and based on that, the engine control through the domain infrastructure, and then the throttle control of that. Hope I am audible.
Yes, sir.
Perfect. Thank you. Going forward, more advanced. So wherever today is mentioned, it is already in the car. Tomorrow we are working on. So rear view, which is basically the lane change assist, and the blind spot detection, lane change, rear cross traffic alerts. This is basically the tomorrow. So these all radars are going to take the data and object detections and all, and then based on the algorithms, the processors or the domain brains are going to take the decisions based on this one. So on the front side, park assist, the front cross traffic alert, junction assist. These are the different types of applications for the front corner and the front radar. Today we implemented the cruise controls and all, but adaptive cruise control, automatic emergency brakings, forward collision warnings. So this type of radar applications we are trying to implement, and CAN-FD and Ethernet is the backbone for all these type of use cases. Then radar is not sufficient. to have a zero accidents. So vision is the next innovation, which is already available in few of the cars. So front view, Wasim, can you switch off these cameras? Anil, your camera is on. Can you? Thank you. So front view is basically a vision based implementation to understand the not just the object detection, but it is visually visible on the screen. So 30% of the rear screen area is going to be used for this type of informations. Surrounding view, driver monitor, perceptions. So very high-end cameras are implemented. A very fast gigabits Ethernet is implemented there for safe and secure automotives. Then different types of other applications, the driving monitoring, monitor perceptions, the 360-degree view, the surround view, the front and rear views and all. So few more cameras, are going to be handle all this type of things. AI is, for the perception based things, and the safety and security is the ingredient. It is required everywhere. So scalable, functionally safe, AI ready vision implementations. So as on today, what type of applications implemented? And tomorrow, this is our target for the surround view. Vision is already through vision we are going to implement 3D segmentation, highway autopilot assist, park assist, pedestrian detections. Although some level of implementation is already there, but the next level of implementation is required in these areas. Driver monitoring through cameras, 3D positioning, driver alertness, and then the driver awareness and different types of camera and radar implementations. The vision related, the object detections, which is pedestrian detections, lateral tracking, automatic emergency braking, collision avoidance, and the rear view, implementation, so that we can see not just in the front, but also across, 360-degree view through these vision implementations. This is, just view of, I think all the sensors are not there, but I tried to capture most of the important sensor here, and the numbers are going to be increasing a lot day by day. So wheel speed sensor, then steering angle torque sensor, car alarm, airbag pressure satellite sensor, airbag, inertial satellite sensor, then comfort of the seat, air bladder sensor, suspension monitors, tire pressure monitoring sensors, radar beam orientation and stabilizations, vehicle movement tracking unit, electric parking brake, hill start controls, navigation, dead reckoning, rollover directions, airbag, central, crash sensor, night vision infrared sensing, electronic stability controls, key fob motion detections, engine air pressure, turbo, LPG, gas pressure, CNG and LPG. Then engine management, electronic throttle, exhaust gas, recirculation, going forward, inverter, battery, DC voltage, charging voltage, and all a lot of sensors are going to be implemented. Brake booster vacuum, pressure, pedestrian impact, protection and low G, and the paddle positioning sensor. These are the few sensor which I captured and put it here on this screen. Apart from this, this is I think only 40% of the sensors implemented in the car. So now you can think of if 6,000 ECUs are going to be part of the futuristic driverless fully automated car, then what type of a very high speed, low noise, low latency Ethernet enablement infrastructure required in the car. This is also one of the area. Now, if we are going to use the car for 4+ hours, then car is not just a a medium by which we can travel from one location to other location. We need a type of aerodynamics cockpits which will beat aerodynamics going forward, if you can see. Then a lot of different types of multimedia support, online downloading of the content, and in-vehicle entertainment will be the most you can say a growth area of implementation. Different types of media support, connectivity through your mobile, everything will be connected. Different types of radios and different types of audio. Bosch is also heavily investing into these areas, and we are closely partnering with them and enabling a lot of infrastructure for them. Now, how different types of applications they are going to be enabled: fully digital e-cockpit, multiple high resolution displays. So I think as on today, our high-end I.MX processors enabling 8K type of or 12K type of display quality, plus 22 different types of LCDs and different types of very high-end processing powers. Media source, smartphone content, apps and services, internet content, radio, DRMs, satellite radio, AM, FM, Bluetooth connectivity and all those things, noise cancellation, engine sound, Dolby Digital, lot of very high-end audio standards to be implemented to give you a very high-end media quality. So what type of services there? And plus a lot of handlings. So starting from wireless charging is one of the area. Then rear seat controls, audio, smart antenna, radio, smart mirrors. So side mirrors will not be, you have to watch. A lot of things will be there also going forward. HUD, hood display, head unit, and then what are different types of application, multiple radio audio sources. As on today, AM, FM, digital radio, DRM, terrestrial radio. So these all, different types of sources, voice processing and analysis, voice recognition system implemented in the car, content and OTA and access security, safe display, camera and audio. Then you have different types of cloud services, e-payment through the car. You can, directly make the payment tips or whatever you want. I'm usually using, very nice videos to define these things, but I will share later. Then driver awareness and 360-degree view of the car. As on today, you are very much aware of when we are doing the reverse parking, we are facing a lot of issues. Still, videos are there. The side uh, 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 black spots and all those things. So for that, complete 360-degree view will be there, not just rear or front, but also side, bottom, top, everything. Machine learning implemented, augmented reality, gesture controls. So this all will be part of a very high-end, fully automated cars. And you can survive only, with Ethernet, very high speed gigabits operations. Plus, only, if all are connected with one network, then it's a problem. That's why the whole car is going to be divided into different domains or zones. And these zones and domains are going to be handled by the local controller, and then local controller is going to be connected with the central gateway, and then very secured communication with the external world with them. So this type of implementation is going on. And the very important part is the OTA services. As you are aware of, so many nodes in the car, and this is already implemented in the high ends of Tesla cars. And you guys are very much aware of a lot of news are coming in the newspapers or through TV channels that few of our OEMs are recalling the cars. A lot of cost involved in that and risk for the drivers. So what they did is the OTA cloud servers. So OTA manager within the car, and different types of OTA servers they are going to make. It's not just one supplier, but the servers are having all the binaries file, and every time whenever we are going to patch the things or new releases will be available, those will be first updated on the clouds. The OEMs are going to first test everything and then going to upload it on the servers. And like you guys are very much aware of, in the mobile updates are available, so this type of message will be there. Or sometimes if it is important, the central console will take the decision and going to update the particular ECU. And once the message is available, the updates are available based on they will create a type of table that what type of which ECU is having which version of the firmware, and based on that, if the latest firmware is available, they are going to update based on some user choices, or some will be automatically pushed on the in the car. So this type of implementation is already implemented in our all the portfolio, and going forward, OTA feature is must in all the applications, whether it is processor based or microcontroller based, and our controllers and microprocessors are capable of handling this type of applications. So you see here different domains like connectivity, which is mainly for secure connectivity network management, then driver replacement, vision, radar, ultrasonics, autonomous in-vehicle entertainment, e-cockpits, and body and comfort, powertrain and vehicle dynamics, engine control basically, gasoline-based, hybrid, and going forward EV. And then the body control domain, HVAC, seat module, comfort modules, which is part of the body and comfort, and all are going to be handled by gateway. This gateway is basically connected with clouds, and the OTA services are going to be implemented by this channel. So through gateway, it will fetch the binaries from the clouds. With the internal table, it will see which node is going to be we have to upgrade. Based on this, the upgrade is going to be happen. And that's all from my side for this one. So our software's at the heart of your car. A lot of guys is working in this area, and the complete transformation is happening in the car. So next not just 10 years, but next 20 years will be growth area for the automotive. So you can shape your career in this domain, and if you guys want to shape your career in this area, so what all is required is, so SoC design, which is basically mostly VLSI expertise, system architecture design, SoC designers, DFT, front end, back end, verification, validation engineers, and firmware and software engineers. So if you want to shape your career in this one, so you can learn C, C++, Python, real-time operating system. AutoSAR is very popular. Linux is nowadays in vehicle entertainment. Android, QNX for graphics. AWS, Azure, and Cloud Array. These are basically the cloud services, hypervisors, virtual machines. This type of implementation, already started within the car. Data acquisition system, data structure, cyber security, ISO 21434, safety, ISO 26262, different types of ISLs. Then the latest technologies like artificial intelligence, machine learning, big data analytics, neural networks, voice recognition, gesture control, augmented reality. These are the few latest technologies which is required for enabling driverless cars, fully autonomous cars, and all. The safe and secure is basically for functional safety. Secure vehicles is mainly for security. Side channel attacks, cyber security we already discussed. Apart from this, a lot of skill sets or expertise required from the applications and field engineering part, which includes field testing, quality engineers, user experience, enabling customers, supporting customers, and a few more so complex software design, LL, VM, CUDA, OpenCL, OpenGL, CPU cluster, DSPs, GPUs, ISP experts, and all. So depending upon in which domain basically you want to work, so very good for to give you a glimpse on what type of different expertise you need, what type of systems you need. If you want to shape your career as an associate designer, what all areas where you can work and all those things. And still, if you need more details of this one, that you want to shape your career in this field, you need some queries, you can use our support email ID. We'll try to support you on that one, or if some issues, you can connect with us through our LinkedIn group, which is NXP Campus Connect group. So with this, I'm open for different queries or questions from your side. That's all from my side. Thank you for your time, and I'm open for Q&A.